Welcome back. So in this video we want to go through some examples that basically show us some examples of polynomial functions, or some phenomena that can be modeled with polynomial functions. And one of the examples is basically the example on page 463 in the book, which is about bacterial growth, which you can find it in the book. And the example is basically like this. There is a table, and it's basically like this. So you have basically, you know that any function is supposed to have, of course I'm supposed to do this straight line. So each function is supposed to have some sort of input and some sort of output. And if you think of this as a function, you could basically consider hour as the input of the function, and the number of bacteria as the output of your function. For example, in the language of functions, you can say, for example, this is something like t in hours, and this is the number of bacteria in terms of t, which is, for example, n of t, or something like that. Of course, I'm just adding this to this. I'm just making this up to make it look like a function, or of course it is actually a function. So in this example, it says when t is equal to 0, when at hour 0, so basically you could say that's where the experiment has begun. So the number of bacteria is 1. When t is equal to 1, the number of bacteria is equal to 2. When t is equal to 2, the number of bacteria is 4. And when t is equal to 3, the number of bacteria is 8. So, and when it's 4, of course there has to be some problem in here. Let me see. So when it's equal to 4, for example, the number of bacteria is 16, and so on and so forth. So you can see that this is a function that's basically the input is t, and the output is basically the number of bacteria as a function of time. And well, the function starts with this initial value. This is your initial value when your t is equal to 0. So this is your initial value of the function. So that is basically your n of 0. And when t is equal to 1, then your function is the output is equal to 2. So basically you're adding 1 to your input. Here again adding 1 to your input, again adding 1 to your input, again adding 1 to your input, and here you can see that your output is being multiplied by some number. For example, here your output is multiplied by 2. So 1 multiplied by 2 is 2. Or 2 multiplied by 2 is 4. 4 multiplied by 2 is equal to 8, and so on and so forth. So basically there are a few things that are important here. First of all, you have this incrementation of your input, which is 1 unit by 1 unit. So that's basically 1 unit, 1 unit, 1 unit, and so on and so forth. The second thing is this So this is one important thing. The second thing is this number by which every time your output is multiplied and then again multiplied and multiplied and so on and so forth. And also your initial value. Your initial value is also important. Now if I want to know, for example, what is n of, for example, 32, or let's say n of 10 here, I would have to then again keep multiplying and adding to inputs and outputs here to get to n of 10. But if I had a rule for this function, I could simply basically calculate n of 10, and I wouldn't have to do all the calculation here. So let's see if we can find some sort of rule for this function. And to find the rule, what you can do is basically your function is n of t. Your function is n of t, and you see that your n of t starts with a value. When your t is equal to 0, your n of t is equal to 1. Your n of t is equal to 1. So this is your initial value. And every time basically your input is incremented by 1, your output is multiplied by 2. So your output is multiplied by 2. Your output is multiplied by 2 every time your input is incremented by 1. And what is your input? That's basically t. So that is 2 raised to the power t. So now what happens here is that, for example, when your t is equal to 0, then 2 raised to the power 0 is equal to 1, and 1 into 1 is equal to 1, which is the value of the function at t is equal to 0. When you increment your input by 1, so when t becomes 1, it is 1 into 2 raised to the power 1. Let me write it down. So n of 0 is equal to 1 times 2 raised to the power 0. So it's 2 to the 0th power is equal to 1. So 1 into 1 is equal to 1. Now if I increment my input by 1, coming here, so it is again 1 times 2 raised to the power 1, which is equal to 1 times 2, which is equal to 2. And again, I'm getting the output here. When my output is 4, again, n of 4 is equal to what? It's 1 times 2 raised to the power 4, which is equal to basically 2 to the 4th power is 16. So 1 into 16 is equal to 16, which is the output of the function here. And suppose I didn't know the value of the function at t is equal to 10. That's what I wanted to calculate here. That I can again do using the rule that we found here. So now n of 10 is equal to what? 1 into 2 raised to the power 10, which is equal to 2 raised to the power 10 is equal to 1024, I suppose. 2 raised to the power 10 is 1024. So 1 times 1024 is 1024. And that is basically the output of the function, even also shown in the book. So that's basically how you can get the rule for this function. So basically you need a few things. First, you need the initial value of the function, and you need to know, I have forgotten the name of this. There is a term used for this number 2 here. I have forgotten the name. I'll find out and do it in another video while we're doing other videos. But basically you need the initial value of the function, which is 1 here, and you know that, for example, your n of 0 is equal to 1. And then this number by which every time the function is multiplied by this number every time the the input is incremented by 1. And of course, it's important to note that the function is, the input is every time incremented by 1. Otherwise, we would have to make some changes to the formula. But as long as as long as the input is being incremented by 1, you can just go with this procedure here. And so so you need this number, which is 2, and then that's it. And then you raise that you raise that number to your variable, which is, for example, t here. It could be x or it could be anything else. So that's basically one example that we can do here. And we will go through the rest of this in the next video. I'll see you in the next video.